are going to be trinomials and binomials. Yesterday they were monomials and binomials. Okay. So the steps are actually exactly the same as yesterday. First find the LCM of the denominator, but I probably would add in like a 1a, like above step 1. You will want to factor any trinomials. First, so that you can find your common denominator. I should say factor any polynomials, because you could also factor a GCF out of a binomial. But oftentimes you're going to want to factor the denominators first, and then find your common denominator. So then we'll, of course, just like we did yesterday, we'll rewrite them using the LCD, and then we'll add or subtract the numerators. So on this first one, we're going to actually be able to factor this denominator, and I can take a GCF of a 3 out of that denominator. So I'll just do it right below, just so I don't have to rewrite the problem. This will be x plus 4 and x plus 1. The other one we can take out a 3. We'll have x plus 1. Now I'm probably going to rewrite this because I'm a little bit, I'm not going to have enough room. Now for those of you that like to show a lot of work, whenever I do this, I'll leave like a little bit of space when I rewrite it, because I'm going to multiply by something in the top and bottom. So I'll leave a little bit of space so I can write that in. All right, now to make the denominators common, it's actually, you're usually just making them match is the easiest way to think of it. So this one has a 3, this one needs to have a 3 also. So I'm going to multiply by 3, the top and the bottom. This one has an x plus 1, this one has an x plus 1, but this one also has an x plus 4, so I need to multiply this one by an x plus 4. So you're literally just getting the denominators to have the same elements. If one had a squared and one had to do it first, you could sometimes do it the least common denominator, but usually getting them to match will do the same thing for you. So I'll have 3 plus, and we'll distribute this because we might be able to factor it. I don't know, we'll see. 5x squared plus 20x. Do not redistribute the denominator, that's a waste of time. And then I will just rearrange the numerator so it's in standard form. So 5x squared plus 20x plus 3 . Now, occasionally the numerator could be factorable. So if this were factorable and it factored into something that matched a denominator binomial, you could cross them out and divide them. But I will tell you this one's not factorable. You would do guess and check. And if you put 3 here and 1 here, you'll get 16x. And if you put the 3 here and the 1 here, you will get 8x. So it's not factorable, but if it were, you would want to factor it and then cancel out any common terms. Also look and see, too, if you could take a GCF out, sometimes the GCFs would cancel out. Okay, next one we have a couple things we can factor. Again, always look for the GCF first before you do guess and check, because it's going to save you a lot of time. See how all of these are divisible by 3? So do that part first. It makes your factoring a lot easier. And the other one I can take a GCF of a 3 out. Keep factoring that first one. That'll be x plus 5x plus 2. Again, I'm going to leave a little bit of space after my first fraction whenever I rewrite this. Now just get your denominators to match so that they each have the same element. So they both already have a 3, they both have an x plus 5. So the only thing you have to do is to the second fraction, you need to multiply it by an x plus 2. The first fraction, you don't have to do anything to it. It'll just stay. So we'll have 1 plus 4x squared plus 8x all over my common denominator. Again, I'd rewrite that top part in standard form, that way we can see if it might be factorable. A lot of ours are not factorable, but that's not to say in all math classes they will be. It just happens in a lot of our examples they aren't factorable. And again, you could trial and error it with your 4 and your 1, or your 2 and 2 and 1, but it will never get you 8. What would I factor this denominator into? Abby? Good. -6 and a +2. Leave a little bit of space. My 3x. Also factor this one. We can take a GCF out. And then how can I make them common? Do I need to multiply which one by what numbers or expressions to make them be the same? Sam?
We need to multiply by 4 for x minus 6, x plus 2, and then we have to multiply x minus 6 to 4, x plus 2.
Good. Again, the more work you show, the better off you are at getting the problem right. So if you try to do stuff mentally, sometimes you'll forget to distribute a number or incorrectly distribute a number. So showing this work is really important to the problem. So we'll have 4 plus 3x squared minus 18x all over 4 plus 2, x minus 6. And then we'll simplify that into a standard form. And then the top one again, if you just want to think it through, 3x and x. If we were to put 4 here and 1 here, that's going to get me 12 and 13. It'll never get me 18. If I put 4 here and 1 here, that's not going to work either. If I put 2 and 2, I'll get 6 and 8. So it's never going to factor. But there is the chance that it could. So always try to think it through. All right, in our last one here on the front, we have subtraction. Okay, so maybe circle that, or I'm going to highlight it on my board. Whenever we go to distribute things, you'll want to take and distribute probably a -4 in this case to whatever you're multiplying. So that way you have distributed your negative as well with the subtraction. So let's again factor anything we can. Now if there's a numerator that needs factored, you can do that too. This one doesn't have any, but what can I take out of this first binomial? Abby? 5. And the second one I can take out a 3. And then don't forget, this is your difference of squares. So this can factor also. So this is going to get me 7y over 5 times y plus 5 and y minus 5. That's our difference of squares where we have 2 different symbols. And we have minus 4 over 3 y plus 5. So we need to get our denominators to match. So this one has a 5. This one doesn't have a 5, so we need to multiply by 5. They both have a y plus 5, so that's good. Bless you. But this one has a y minus 5, so we need to make this one also have a y minus 5. So the first one, I also need to not forget that this one has a 3, so this one has to have a 3. I almost forgot that. So we will get 21y and when you multiply this together, you want to include that negative sign. So this is -4 times 5, which would be -20, which you're then going to distribute to each of your factors. So this will be a minus 20y, and it will be a plus 100, because the minus and negative becomes a positive. And if you want to do that piece by piece, you can. And that's all over our common denominator, which would be 15. Y plus 5, y minus 5. And then the only thing we can do is combine our like terms in the top. 21 minus 20 is 1. Y. All right, show of hands, how many of you think this is hard? How many of you think it's easy? How many of you think it's in between? Okay. Let's do like 2 more and then I'll have you guys do 7 in the closure. Remember that if there's a leading coefficient, always check for a GCF because I don't want to have to think of factors of 105 and guess and check them with a 3. Don't. So see if you can factor out 3 from 105, which we can. Well, actually, let me do that down here. So we'll get x squared plus 12x plus 35. A lot of times they will have a GCF so that you don't have to do your guess and check factor. Then we'll factor that down into what binomials? Ashley? Good. Plus 5 and plus 7. This is a minus. So again, draw your attention to that you'll have to distribute a negative when you do this. 3x over, and our GCF here would be 6. All right, now, if you notice, 3 and 6, we don't have to multiply this one by 6 and this one by 3. Between 3 and 6, the common denominator would be 6. So if you want to do the least common denominator, you really just have to multiply this first one by 2. That'll get me 6, which will match the 6. If you don't notice that, it's okay. You'll just have to simplify later. All right, now this one already has a 6, and it has an x plus 5. So we just need to do an x plus 7 on the second fraction. So we'll have negative 4. Again, when we distribute, this is going to be a negative 3x times x and a negative 3x times 21. So this will be a minus 3x squared and a minus 21x. And then the only thing we can really do is rearrange that. You could factor out a negative. Like if you notice the answer key will sometimes do that. You're not required to do that. But since the negative is in the front, you could factor out a negative. And again, this wouldn't be factorable because whenever you have 3 and 4, they're never going to get you to 21. Actually, why don't you guys try 6, and then we'll do 7 together because it's actually a harder one. So try 6 on your own because it's a little bit. This one, let's go ahead and factor our denominator. So let's take out a GCF first. Now always check, because if these were the same, you don't have to do anything. So like if the denominators were both 3x squared minus 9x plus 6, you could just add the numerators. Sometimes that will happen, but and x squared plus x minus 2. We have a subtraction, so remember to distribute a negative. So this will be equal to x minus 2 and x minus 1. Now this 2x plus 1 in the numerator, I'd probably stick parentheses around it since it's a binomial, just to remind myself it gets grouped. And then in this denominator I'll have, what will that factor into? multiplies to negative 2, adds to 1. Awesome. Good. All right, so they both have 3's. We're good there. They also both have x minus 1's. We're good there. But one has an x minus 2 and one has an x plus 2. So we actually have to multiply both of them by the opposite function. So we're going to put an x plus 2 here, top and bottom, and we'll have to put an x minus 2 on this one. Too bad they're not the same sign. So on the first one, we'll distribute that to get x squared plus 2x. Now in this one, I am going to leave the minus sign. Well, maybe let's just do 2 fractions. And we're going to have to FOIL this. So drop that down in your notes. We'll get 2x squared minus 2x, no, excuse me, minus 4x plus 1x minus 2. We didn't have to do that underneath the notes. And then you can combine your like terms, which will get me at 2x squared minus 3x minus 2. And then the common denominator, of course, is common. I'm just going to like leave that off, but you know what it will be. Now we have to distribute our negative sign to all of those 3 terms in the trinomial before we combine our like terms. So we'll have x squared plus 2x minus 2x squared plus 3x and plus 2 all over our common denominator. And if you're like me, someone who hates rewriting that denominator a million times, you can just simplify the numerator and then at the end stick the denominator underneath it, so you don't have to write that like 5 times. But at least show the workbook this part. So we should get negative x squared plus 5x plus 2. And all over our common denominator. All right, now before we do the closure, I want to draw your attention to actually what Colton just asked me about, because we didn't do any like that in the notes, and I feel like a couple of you will try to do this on the homework. So down somewhere in some space that you have on your note sheet, you just go to a blank slide. So we have a binomial and a monomial. The question that was asked was, can I just subtract 1 from each of these? The answer is no. So you have to think of this as being a binomial. And this is a monomial technically by itself. In a just like in a fraction, if you had like, could I make this 1/2 by just like subtracting 1 from it and then add them together? No. When you make a common denominator, you have to multiply by something, not add or subtract. So for this example, what you'd have to actually do is multiply this one by x squared and multiply this one by x squared minus 1. So just be aware you cannot add or subtract numbers to make a common denominator. All right, take a glance at the closure and see which one you think it would be. Multiple choice. Anyone get an answer? Jade? Lexi? H. So we should have multiplied this one by an x minus 1, and this one by an x plus 1. And so that'll give me 2x minus 1 plus 2x plus 1, which will divide, cancel each other out. Excuse me, 1x plus 1 and 1x. So that's getting me 2x.